All right, so we're going to talk about chapter 14, water. We are going to do the central case study a different day, so I'm going to just kind of go over this briefly, and then you should kind of think about these questions throughout this lesson, and then you'll be doing the central case study next class. All right, so the 2,300-kilometer Colorado River once flowed deep and wide across the Southwest to Mexico's Gulf of California. There was a Colorado River Compact, which was an agreement in 1922 by 7 states where they agreed how they were going to use that water for human use. Now, today, due to drought, dams, and diversion, this once raging Colorado River is now nearly dry. Now, because of this, the people in those 7 states still need water. So officials in Las Vegas, Nevada, have turned to an unlikely source for water. They've proposed to mine groundwater from beneath the Great Basin Desert. And this is controversial. It would affect the ecology. It could affect the water tables of other areas, so the access of groundwater of people in other areas. And it could also affect the other people who need water as well and don't have like the money or the equipment for the mining, because Las Vegas, Nevada is going to be a richer city than a lot of the other cities and towns. So think about, is the human need for fresh water reason enough to mine in an area that might threaten ecology? And what other ideas could states in the Colorado River Basin try? All right, 14.1, Earth, the water planet. Although the vast majority of Earth is covered in water, 1 in 8 people lacks access to clean, fresh water. And we talked about this a little bit in one of our earlier chapters, that access to clean, fresh water really keeps people healthy. It prevents diarrheal diseases and a whole bunch of other different kinds of illnesses. So this is a major issue. All right, on Earth, fresh water is present in rivers and lakes. We're going to talk about where that is. It is a renewable resource, but it is also limited. In many areas, we are using it faster than it can be replaced. And I want you to kind of think about, Earth is sometimes called the pale blue dot in space because it is covered in water. But if you take all of Earth's water and you pretend a 2-liter bottle is all of Earth's water, only about 2 capfuls would be fresh liquid water. The rest of that would be salty, or it would be like stored in ice caps, things like that. So we don't really have that much fresh water. We have a lot of salty water. And the fresh water is distributed unequally. How much water people use depends on where they live. It depends on the time of year. And then their availability, like the access to that, is going to depend on things like that too. For example, in Canada, they might use fresh water to cool down the machinery at a coal power plant that produces electricity. In the winter, they're going to use more water because they're producing more electricity to heat homes. In New Mexico, to go back to the central case study, they might use more water during the growing season to irrigate farms because it's the desert. So we're going to see that water usage is going to vary quite a bit. And those are 2 of our main uses, like industrial and then agricultural. So there are other uses of water as well. Here's a nice map of surface water. This is showing us the river watersheds. Surface water also includes lakes, but we're going to talk about rivers and watersheds first. So a watershed is the area of land that supplies water to a river system, and every waterway will define a watershed. So you can see that all the green rivers eventually flow to the Mississippi, so that's the Mississippi River watershed. You'll notice that the Atlantic slope is not named after a specific river. That is because we have a number of rivers that exit into the ocean. So we've got, just in the city of Atlanta, we sit at the center of 3 different watersheds. So there's lots of different watersheds along that Atlantic coast. All right, groundwater seeps through the soil and becomes contained in underground aquifers. So it's actually held underground in these porous rock layers. The aquifers are permeable, so they can hold onto water, but it's like rock, but there's holes in it. The water table separates that zone of saturation, where the rock is filled with water, to the zone of aeration, where there's no water in the rock.